Hello, everyone. Welcome to our open day for the Bachelor Data Science and Artificial Intelligence. We have a 2.5 hour schedule today. First of all, I will tell you something about our education program. Then we will have a small lecture on artificial intelligence itself, and at the end there will be a 1 hour long Q&A session with two other students, including me. There you can ask all your questions. If you have any questions in the meanwhile, you can of course send them in the chat, and I will try to get to them. But do remember that we have an extra hour at the end for all the questions. Um, so first of all, I will tell you for half an hour something about our program. Some of you might already have seen this presentation at the previous open day. Um, yeah, you can follow it along again. You can also leave for half an hour and come back at the lecture. Um, so let's get started. Um, so first I will introduce myself. I'm Job van Dijken. I'm the student ambassador for data science and artificial intelligence. It's my role to host this day and to tell you something about our bachelor. Usually this presentation was given with someone else. Um, Today I'm doing it alone, but there will be other people today. Um, let's get to it. Okay, so we have a few things that we will discuss. Um, First of all, I will give you a broad overview of what data science and artificial intelligence is. Then I will tell you something about the program structure. Then I will tell you something about why you should choose for Leiden. Um, then I will show you um, where our faculty is. Then I will tell you something about the student life, the career options, and finally something about the admission and the matching process. Okay, so what is artificial intelligence? Um, well, the definition of artificial intelligence is researching and designing information processing, excuse me, with as a result intelligent behavior slash decisions by technology. Well, this might be a very broad definition. Definitely does not include everything of it, but it does get to the core. There are two main fields that we specify in Leiden, the two different fields. First of all, there's technology. Yeah, this is of course like in computers and the general artificial intelligence that we think of. And then there's in humans and animals. That's also something we do research in Leiden, and that's mostly known as cognitive science. But these two are really well connected, and sometimes the partition even becomes quite vague. Well, here you have a typical development cycle, or not development cycle, think cycle of a uh, artificial intelligent agent, something or someone that thinks in a intelligent behavior. Usually, it's a three-step process. This is a very well-known process, and you'll definitely come across it in the study. Um, it exists of three parts. The first part, or not the first part, it's actually a cycle. So anything could be the first part, but the part at the moment most to the left of us is the sense part. You feel something. Um, yeah, the wall is 4 centimeters away from me. You don't actually already do something with it. You just notice it. Well, once you have noticed it, then you come into the think part, and that's where you are actually going to think about it. So first, you're only going to notice things, but you don't actually process them. You just, hey, the wall's 4 centimeters away from me, and only then you're going to think, oh, that's way too close. I'm not going to stand 4 centimeters away, or 4 centimeters away from a wall. And that is also the point that you decide that you're going to act on something. So the think part is also known as the decision part. And once you have decided that, you're going to act on it, carry out the decision, um, and going to move away from the wall. And after that, we're going to come back to the sense part, the noticing part, um, and you will think, hey, the wall is actually close enough or far away from me that I'm comfortable. And then you might make another decision and act on it again, and then you will sense it again, and that will continue forever. Yeah, a few more examples. The logical reasoning part of artificial intelligence is, of course, a big part. You could see it as the think step in the sense think act cycle. On the right top, you also see BDI agent. It's basically the same as the sense think act. So yeah, logical reasoning. This is the step of yeah creating a decision from what you have. So it includes logic, deduction, planning, and decision making. And this is could of course be seen as one of the largest thresholds we currently have because it might be the hardest thing to do because you have to understand what is a logical thing even to do. What decision is a good decision? What decision is a bad decision? Then you also have to, with all the information you get, to make a to see what's good information, what's bad information, and just what to discard. Uh, then you also have to know what at this current moment is important and what is not, because some information might be important, but you can just discard it as this at this moment, and it might be interesting at a later moment. Uh, and then finally, the decision making. Uh, at the bottom right, you see a few different levels of logic. Uh, and these are, of course, very well known also in the computer science world. You see somewhere in there the and, or, not, if, and then symbols. They're, of course, very often used in computer science programming. And you also see then predicate logic. And predicate logic also includes quantifiers. So how many of something, all husband cheat. If all colleges are bad, CMU is bad. At least one chinchilla is smarter than at least one human. And then the temporal logic, which also includes time. Eventually, all humans will die. I always tell ducks not to panic. Um, the temporal logic is, of course, the most well-defined and most interesting logic, but it might be hard to tell a computer how to act on it. While the propositional logic is much faster, much simpler, and this might also be more usable. Usable. So you want to use the temporal logic. Um, so that's of course a decision process. Now, another part is the data-driven learning. Um, in artificial intelligence, learning, as we see it, is one of the another really big part of the decision process because when the world changes, you want to change with it, and you don't want to define for every state the world can be in a whole new subsystem of what it should do. Now you want it be to change on its own to see, hey, last time I did this, didn't go well. Now the world changed to this. I should probably now do this. Just learn on its own. Um, yeah, you have probably already seen it quite some time. Machine learning is a big part of it. Uh, Optimization, it's a lot of mathematics included. The neural network, you see it on the top right. It's just trying to recreate a brain. Doesn't always succeed, but sometimes it does give a really good outcome. Um, and reinforcement learning, just keep trying, just improve on yourself just as long until it works as good as you want it to. And these are all things that you will come across in the Bachelor, and you will do some things with them yourself. And then there's often the view that that artificial intelligence should be in a body. Um, this, of course, doesn't have to be, but uh, we do like it that it is. So you see the virtual characters that could be in a game, for example, that you're playing against bots. Well, these bots also have to kind of think. If they see you, they might have to do something. If they don't see you, they shouldn't do something with you because they don't know you're there. That's also some kind of artificial intelligence that is there. Um, yeah, the robots you see at the top left, you see a robot. Well, that's basically just a robot with another sense, think, act cycle in its head, or maybe not in its head, probably in its body, because why would you even store the computer in its head if you have much more room in the body? Um, and uh, so it doesn't really need to have the body, but it is nice because we as humans think that it should have a body, and we view it much more as a human if it does have a body. In the top right corner, you see another robot. It looks kind of scary. And this robot uh, still has the same sense think act cycle, but because it looks so human-like, um, we think it is more human than the robot in the top left corner, which is a car. Still a robot, probably. It drives itself. It still has the same sense think act cycle, but it's probably much more advanced than the robot in the top left corner. But this might be a good example of how we sometimes view artificial intelligence in different ways, um, because we don't always judge it in the same way. Uh, and then there's the psychological basis. It's multidisciplinary. It's something in psychology, but it's also in neuroscience, I think. And you will come across it in the bachelor as well. It has a few courses, but not that much, but I will get to that. First off, there's the cognitive psychology, the more regular kind of psychology. Then there's the cognitive neuroscience. Um, yeah, you will have one extremely broad course on that. It is a fun subject. It's more about the neurons in your brain, how they fire together, why some decisions are made at a certain place in your brain, and um, what certain brain areas do and what happens if they fail. Philosophy of mind, just a really small ethics part, um, and user studies, how people interact with it. And of course, this basis, it does not always seem too important, but if trying to recreate a brain, it might be useful to know how it even works. Okay, so now we'll get to what you all will come across. So first of all, cognitive psychology part, just like I told you, how does the brain process information, how to model these processes, how to program these models. Um, and this is quite a big part of the bachelor, and it's the thing that the regular computer science skips on. Um, so that's only in the AI bachelor. Then the real core AI subjects, how to get computers to reason, how to get computers to learn, and how does this connect to mathematics. Um, and mathematics and AI are probably much closer related than you realize, because behind every reasoning model, behind every learning model, there is always and almost always uh, a mathematical model behind it. And then there are the research methods, how to set up a survey, how to analyze data with statistical models, that with statistical methods. That's probably the data science part of our bachelor, and how to set up a simulation. Okay, so here you see the program structure. It's a 3-year bachelor. It has 180 EC, like every 3-year bachelor. In your first year, you have to get 60 EC, and in the to get your proprietor. In the second year, it's again 60, but we don't call it a proprietor anymore. And in the last year, it's again 60 EC. There is a binding study advice, the BSA for short, or bindend studieadvies for the Dutch students. It's 45 EC, and that's the minimum requirement you need to get for a pass in the first year. If you don't get that pass, you will have to drop out. We will get to it a bit more, but do remember that 45 EC is really important, especially if you're international, because yeah, you might have come to the Netherlands for this specific study, If you don't manage to get to 45 EC, you have to drop out. And that would, of course, be a shame. On average, there's about 20 connect hours a week. That means that on average, there's about 20 hours a week that you will have to be present at either a lecture or a work group. And we don't always succeed, to keep a maximum of 30 students in one exercise class. So you get a lot of personal interaction. If you have a question, you will get helped quickly so you can go further. And that's really what Leiden focuses on, keeping those groups small, keeping the education just of high quality instead of quantity. So on the right, you can see the division between the different disciplines. 45% is still just regular computer science. So at the end, you will be a really good computer scientist. No doubt of that. Then 40% is data science and artificial intelligence specific. That's still like almost the most of your bachelor, but you do still need that computer science background to even succeed in it. So that's why there's still more computer science than data science and artificial intelligence courses. But they are almost 50-50. And one might see a data science course as a computer science course, or some people see a computer science course, for example, natural computing, that could be seen as a computer science course, but could also be seen as a data science course. Then there's 10% math, but again, some people might see a math course as a computer science course, and some people might see a computer science course, such as Introduction to Logic, as a math course. So these can be sometimes multidisciplinary. It might not always be such a hard division, but this is about what each discipline takes up in the program. And then there's a small part of academic skills, writing a thesis, those kind of things. There are multiple forms of education. There are, of course, lectures, just regular one-way conversation between you and the teacher. There are work groups. That's what you see on the top right, people sitting behind a computer and teaching assistants helping them. Then there's, of course, practical coursework. Those might be papers that you have to write at home. And then there are exercise classes. Just you get a sheet with exercises and a teacher that can help you with them. I already mentioned the student assistants or the teaching assistants. Not every lecture might be given by a professor or researcher. Each professor has to give also a lecture, so that's why every researcher is also a lecturer. But they might also be given by the PhD students or the student assistants. That's just to get some load of the teachers and to give you a more personal feeling at the lecture. Okay, so here we see the first year, the courses in it. I won't go through every course, you can read it for yourself. But the courses in orange, those are the regular computer science courses. So you see about 50% is here computer science. Then you see the blue courses, those are all mathematics. Then you see the purple courses, that's a slightly weird course. It's an introduction course. And then you see the green course, and that is a psychology course in this case. And then you see the gray course, and that's a cognitive neuroscience course. So about 50% computer science, 40% math in the first year, and I think 10% psychology and 10% cognitive neuroscience. And if you add all those percentages up, you get to 110%. So it's about. Then in the second year, you already see a lot less of regular computer science and a lot less of mathematics. That's because now with these computer science bases that you have got, we are able to do some extra uh, data science and AI things, such as machine learning, cognitive robotics. You need the basis of computer science to even get to those courses, but then in the second year they do take up much more of your schedule. You also see the introduction to behavioral data science. Um, that's also an AI course. But you see that it does have a different color than cognitive neuroscience. That's because they are in quite different fields in the AI. Data science, it's much more data science related. Um, and the cognitive neuroscience is much more um, yeah, cognitive neuroscience related. The courses say themselves, but they are different elements in the data science and artificial intelligence spectrum. So it is a wide spectrum, and that's why it has a lot of courses. And then in your final year, you can do or these are just the subjects: software engineering. You're going to create your own software, natural language processing, and you see at the right part the bachelor research project. That's a thesis. You have to do it on your own. It takes up the last quarter of the year, and that's also how you're going to enter bachelor. And then you see the electives, minor, or study abroad. That means that you can either go study abroad. You can also do it in your second year, uh, or you just choose a minor, or you just choose a few different courses. Um, it's up to you what you want to do in that time. Those electives can be, for example, introduction to video game making or computer graphics. Okay, so why should you go to Leiden? Leiden is the oldest university of the Netherlands. It's not that you will really do something with it, but it is fun to know. It is a real well ranked university. A lot of different countries have relations with them. People know of Leiden when you go tell abroad that you studied in Leiden, and it is a research university, which means that if you graduate, you can come back to Leiden and do your research there. It's not only focused on the education part, and that's also why we get a lot of good professors that teach courses because they want to do research at Leiden. It also has a great student life, um, and at our specific program, we believe that uh, computer scientists should just be as much a thing as being good as a scientist. These two are not independent of each other, and that's why you, at the end of the program, will be a good programmer. Well, we are running a bit out of time, so I will be a bit quicker now. These are the buildings that we are in. They're all located in Leiden. On the bottom left, you see the old Galeus, but that's going to be removed. Next to it, you see the Leiden Bioscience Park. It's just where all the buildings are located. Next to that, you see the new Galeus. And next to that, you see the Snellius, which is the building of the computer science programs in general. Um, so what can you do with for the student life? Well, there's the study association. It's a shared study association among physics, astronomy, math, and computer science. It just organizes things such as a first year weekend, among some other fun activities. Then there are student associations. I do recommend these to everyone. They're just a lot of fun. They're with all the other faculties in Leiden combined. So you might also be with some law students. Um, for the international students, each year the Leiden is so much growing. So it also became much more fun for international students in the last years. Um, if you do want to go and live on your own in Leiden, you do need to keep in mind that housing is really limited. Leiden University does or can support you in some way, but it's so limited, so you have to be really quick on it. It's not impossible, but if you want it, you need to go for it. Well, what can you do after the bachelor? Um, you can do a master in computer science. You can just, instead of going for AI, you can just go further in computer science. The master ICT in business, master computer science in the public sector. So these are all computer science related masters. But you can also do psychology masters. Not every psychology master, and for some you will need to do an additional transition year. But there are quite some psychology masters that you can do. And then you see the masters elsewhere in the Netherlands, such as the AI master in Amsterdam or in Utrecht. Um, as of this year, there's also an AI master in Leiden. So if you really want to stay, you can stay and just continue with even more artificial intelligence. So what to do after graduation, either after your bachelor or after your master? Yeah, of course, you're going to follow a career. Um, yeah, if you are graduated, it won't be hard to find a job. About 97% have a job after they graduate, and it takes about 1 month to find a job. So that's of course incredibly short. Um, it's even shorter than your summer holiday, probably. You can just become a software engineer. That's still what a lot of people do. You can become a data and AI specialist, consultant, machine learning engineer, a data scientist, or a business intelligence developer, where you really use your knowledge in a practical field. Okay, so the admissions. For Dutch students, all you need to have is just Mathematics B. If you don't have Mathematics B, but you do have something else that might be enough, then you can always send an admission request. For international students, um, you either need to get 60% at the OMPD test, or you need the Mathematics B certificate at Boswell Beta. Um, for Dutch students who don't have Mathematics B, you can of course also get that certificate. Then there is an English requirement, and it's either one of these two tests you see on the bottom part. You can just choose which one you're going to take. Well, if you still want to know more, you can send a message to me, and I will arrange a meeloopdag for the Dutch students, or a tour of the campus for the English students. You can contact me at my email or chat with me. So this was it. It says Q&A, but you're first going to have the lecture. This will be done by a professor, and after the lecture there will be a Q&A if you want to join that. So see you guys in an hour.
Roy. En allemaal. Oké. Ben ik te verstaan?
Ja.
Oké, dat is mooi. Zeg, ja, kijk, dankjewel. Daar is Cara Omnia in de chat. Dat is mooi. Ik hoop dat ik die naam goed uitspreek.
Max, ik
Is
onderbreek
hier...
je even.
Ja, precies. Een
Kan je
moderator.
het in het Engels doen?
Ja, dat kan ik zeker. Maar is er iemand die dit modereert? Job, ben jij er bijvoorbeeld?
Ja, ik ben er.
Jij bent Job. Oké, goed. Ja. Wil je nog een aankondiging doen?
Die hebben ze al gehad. Ze weten wat er gaat gebeuren.
All right. Okay. Then I'll take it from here. So I will share my screen. So, okay, so there has been an introduction, I understand. See if I can share with you my slides. Not very easily, it seems. So my Teams is currently loading the screen for sharing content. So Job, what I will do, I will now send you an email with my slides, and hopefully you will be able to share your screen and do it in this way. I will also send it to Roy just in case. So, and for the students who are here, so teaching happens either in Zoom or via YouTube stream in the program where I am affiliated with. So Teams is what I use sometimes for meetings, but not necessarily for teaching. So forgive me for this bit of technical hiccup, but it doesn't seem as if content sharing is something that works right now. So it's coming your way.
You can also share PowerPoint directly in Teams. If you click on the share content button.
Yes, so the thing is that the share content button is loading since we started the meeting. So it hasn't done anything since. Okay. Okay. Then
I'm still waiting on the slides.
Yes, they should arrive in your email box shortly. Now, meanwhile, let me say something very briefly about myself. And so something else, when I teach in the master's program, media technology, which is my main affiliation with the Leiden Institute of Advanced Computer Science, the institute that also hosts the Bachelor in Data Science and Artificial Intelligence. We have a webcam protocol, which is basically that everybody is in the master's course is even obliged to put on their webcam if possible. Now, of course, we can't do that here, but I would like to say that I would much appreciate if at least everybody who feels comfortable putting on their webcam and who can put on their webcam would be happy to do that, because currently I'm really literally speaking in a void. So I can only see my colleague Roy, whom I like a lot, but it would just be wonderful if we can see some of the titles. Job, hello, good to see you as well. And yeah. Now, my name is Max van Duin. I am a researcher and lecturer here at the Computer Science Institute in Leiden. I have a background originally in linguistics, and besides linguistics, hello Tom, good to see you too. And now there are more coming. I can't read out all the names. Hello, hello. This is a lot more pleasant already. Thank you very much. Now, I have a background originally in language and literature, stories, philosophy, so let's say humanities disciplines. And after that early background in my bachelor's and a bit of my master's, I went into the cognitive sciences, which is basically studies of the mind. And that took me some years later to the UK, where I worked in a lab where basically cognitive science, neuroscience, and artificial intelligence were combined. This is when I got back to the Netherlands also what I picked up here. And I'm currently involved in the Bachelor Data Science AI as a lecturer for the course Orientation AI, together with Maarten Lamers and Peter van der Putten, who are both fully blown computer scientists. So the synergy in that course is really that there's someone with a somewhat different background lecturing together with someone from computer science. And that usually leads to interesting discussions. So the way we work in that Orientation AI course is that we try to go a bit more to the fundamentals of what intelligence is. And we see intelligence as a phenomenon that can be implemented in biological substrates, in biological systems. That's, for example, ourselves, but all many animals qualify as well. And of course, intelligence can be implemented in silicon-based devices or in artificial creatures, artificial systems. And now I see Maria raising a hand. No, that wasn't Maria, that was someone else raising a hand. Okay. At least, Job, I would like to thank you very, very much for sorting the slides. That is really, really useful. Yes, so here is a little bit from the Orientation of Artificial Intelligence course. And today, of course, Roy de Klein is also joining. I think Roy will, when he takes over about halfway, say a little bit more about himself and his affiliation with the program. But for now, it's good to know, Roy, that you're here and that you're willing to co-lecture with me. But originally, this course is a co-lectureship between me and a computer scientist. And we do a lot of discussions also, pretty much in class, where we, well, really try and see what these different perspectives are. Because we believe, and that's the first slide, so there's a lot of clicking in the beginning, because the first slides are just a list. Job, I think you are the only one who can click, right? Or can I do that myself? I can even do it myself. Wonderful. So when we think about artificial intelligence, and especially, I would say, your generation, who have grown up in a world where this, where the field has basically been there for all your lives, well, that goes for me as well, because I would argue artificial intelligence started quite a bit earlier than in the current sort of rush we are now in. Yeah. So, and the course Orientation AI also really dives a bit deeper into the history of the discipline by thinking a little bit about, as we will also see today, even Turing and the 1940s, 1950s take on intelligent machines. Yeah, but for your generation, I think AI is often associated with a couple of really, say, present day examples. Yeah, so self-driving cars, robots, humanoid robots in this case, but of course robots can take many, many shapes. This is, as you will probably all know, the spectacular beating of Lee Sedol, the world champion in Go, by an algorithm called AlphaGo. Robotics taken into hospitals, into all kinds of schools, etc. That's the kind of things you might associate it with artificial intelligence, as well as the fictional stories. So this is even a bit further down the humanoid line, a film reflecting on some of the possibilities that AI may hold for us in the relatively near future. Yeah, so funnily enough, it says coming soon. This is about coming soon, the movie, but in some sense, this is also about coming soon in our lives potentially. Yeah, so another movie I like pretty much, and I also tend to discuss in class, is the movie Her, where it's basically just a voice being pictured, yeah, an operating system, and a user falling in love with that system. And it's really very interesting if we need to think about actually what artificial intelligence is. And that's really what we see as the purpose of this Orientation AI course. Yeah? So the purpose is not to teach you new skills. There's lots of courses in the program that teach you new skills, new techniques. The course Orientation AI is really about thinking. And I would almost say, so if there's skills being taught, then this is the skill of being critical and being happy to accept that lots of multiple perspectives are being thrown at you at universities, and that this means that you will have to do some of the integration of this yourself. Yeah. So in this course, it's usually not done to ask, is this and this true? I think you have to do things. Slide. Okay, so that means that everybody needs to do the clicking themselves, because I'm at slide 7 of 31 at the moment. Yeah. So is this the case? Does everybody have to do the clicking by themselves, or Job, if you click, what happens?
I think Job does the clicking for me at least.
Yeah, I'm doing it for everyone.
Okay, so if I click, that's interesting. I see something else on my screen. However, I don't. This is not in your place. As said, I mean, in Zoom and the YouTube stream world, I'm pretty well versed, of course, after 2 years of hybrid teaching. In Zoom, in Teams, I haven't done it before, so sorry for that. Job, slide 7 of 31, is that correct? The moment. So there's 3 magazines. We can also safely go to 8. Yeah, so there's of course also the dark side that we are confronted with every now and then. Will robots destroy us, take our jobs, etc., etc.? Another interesting thing to reflect on. Yeah, so the orientation AI course also includes a movie night where we see the movie The Matrix, plus usually also 2 or 3 experimental short movies. And the movie night is usually a place for discussion. Of course, The Matrix is a classic movie about this dystopic scenario of AI taking over and using us as mere batteries. Yeah, but this is, so even though this is popular culture, it does spark very interesting discussions, very fundamental discussions about the relationship between humans and machines. And that's really what this course is about. Now, very briefly, this is the final bit of very introductory before I go a little bit more into detail. But this is another thing that we tend to watch. Yeah, so this is clearly because I haven't prepared the slides, of course, for next year. So if you would take this course next year, the new updated 2021 Gartner's Hype Cycle slide will be included. Yeah, but the interesting thing, so this is still the slide from the previous time I was teaching the course. But this is something we also tend to follow, and it's interesting. This is a curve that you need to read the other way around. Yeah, so the technologies that are upcoming or expected to be upcoming are those to the left. And the interesting thing is here that if you look which ones pertain to AI, yeah, that is nearly 70, 80% of them. Yeah, although this is a general technology hype cycle, so this is really the technologies expected to be influential in the years to come. And this is also an important reason, and we can go to the next slide, please. This is also a really important reason why AI has been for at least 20 years on top of the list. If you ask people in any discipline in academia, what is the discipline you would like to be in if you would have to choose your subject now, then people across all university disciplines, yeah, that is ranging from mathematics to physics to biology to humanities, philosophy, yeah, they need to list which discipline they would choose if they would have to choose again. And artificial intelligence has been very, very high on the list in many years. On top of that list is an American list, which is no surprise if you think about it. So I'm now at slide 10. Is that correct? What's AI? Is that correct? Yeah, okay. Very funny system this. So clearly not state-of-the-art AI we're using for this presentation. So this begs the question: why is this field so appealing to many? And my own take on this is that artificial intelligence is a field where you can actually do, say, thinking with a hammer, or even you could even say philosophy with a hammer, or in some sense also biology with a hammer. And what I mean with a hammer is that you can take the roll up your sleeves approach. Yeah, instead of just thinking about clever systems, instead of just studying some animal. Yeah, so where I was working in the UK, there was a very interesting fruit fly lab. So they were studying fruit fly intelligence. Very interesting. But at some point, I saw that they were not really hiring that many biologists anymore. They were hiring AI people, because the next step was basically that you don't need the fruit fly anymore. You simply model fruit fly cognition, and you can do even more interesting things with that. Yeah. So the point here is that building artificial systems definitely has lots of interesting applications, and we went through a few, ranging from self-driving cars to help robots to robots that may from which we may even fear that they may at some point threaten our jobs. Yeah, which is a discussion that is not for today, but it's definitely also a discussion that is part of that orientation AI course. So these dystopic scenarios of maybe AI being threatening to us is a very interesting topic, and not a topic where I myself am so afraid of, as public opinion tends to be. But let's for now say these applications are all important and interesting. However, AI as we see it in this course, and I think that's more generally true for a lot of courses in AI at the university, is often less about these applied systems. Yeah, so let's put it this way: that is really important for most of you, probably later in your lives, when you go into having jobs with your AI education. But your AI education is also a lot about the fundaments of intelligence, the fundaments of intelligent systems, meaning that you cannot just do very handy and sophisticated things with AI. You can also make relatively simple systems that lead to insights that you could otherwise not have gained. Yeah? And so what I mean by that is that relatively simple models, relatively simple small robots that maybe Roy will say something about, because I know he's very fond of these, can actually teach you extremely instructive things that you could not have learned otherwise. Yeah? And that's my own take on why so many people would actually like to be in AI nowadays in academia, because their fields, ranging from philosophy to biology to the cognitive sciences, it has often been pretty hard to study cognition from the outside, whereas in AI you can actually, well, study it from the inside, in the sense that you can build things and really manipulate them and use them in experimental ways, and even say tinker around with intelligence, quite literally. So you can take a playful approach to studying intelligence if you are an AI researcher capable of actually building some of these things, as you, if you pursue this program, will all become very soon. Now, okay, wanting to build intelligent systems for whatever use, yeah, for answering interesting research questions across all fields, but also for applications in industry and society, yeah, can be categorized in different interesting ways. Yeah? And there's no time to really discuss all 4 of those bullets in more detail. That's really something. Oops, I lost the slides now. Is that something that you all did? No, I don't see the slides anymore. Do you still see them? Wow, this is amazing. Right.
I'm fixing it.
Thank you so much.
It's coming back.
Yeah. Okay. Yeah. Well, one big advantage is that now I see, so I won't touch the clicking anymore. Yeah. Yeah. So because now I also see what Job does, and that is very interesting for me. Now, like humans, and ideally, yeah. So this little matrix that you can see here comes from a classic book by Russell and Norvig, AI: A Modern Approach. And you see the date on the bottom right of the slide. Yeah, so that date is probably before most of you were born, 1995. And this is really, I would almost say, a hobby that Maarten Lamers, the other teacher, the computer science teacher of this class, and myself have, is that we quite often use older texts in our teaching. And this is a little bit a decision to go against the grain of what you will probably meet in most other courses, yeah, because this is a very fast-moving field, and especially when you learn new skills and techniques, you need to be up to date. And a paper from 3 years ago is probably already old, and let alone 10 years ago. Now, what we try to do is really also add that more, say, historical, not really, it's more like some depth to AI discussions, by also sometimes reading things that were written longer ago, before actually the latest revolutions materialized, and see how very clever and inspiring people in these periods saw artificial intelligence before actually some things were possible. Yeah. So now we went to the next slide. That's actually okay with me. I didn't ask for it this time, but it's okay. Now, so, or maybe go back for 1 second, yeah, to that slide number 10, please. Yeah. What we mean by this little matrix, yeah. So thinking humanly, thinking rationally, acting humanly, and acting rationally, is a division now made in the 1990s, as you can see, but I think it's still very applicable to discussions today in artificial intelligence. Yeah. So first of all, thinking humanly, that is really the subfield that I think the cognitive sciences are most interested in. So the cognitive scientists, psychologists who use artificial intelligence to answer their questions. Thinking humanly, you can also say, not necessarily humanly, but thinking biologically. Yeah, so thinking like brains do. And then there is so to the right, this thinking rationally bullet is much more about one specific kind of idealized reasoning that brains actually are quite often not very good at, but that has nevertheless been part of what has been considered intelligence for many, many ages. Yeah, so this tradition goes back to the classic period. Yeah, so you can really so Aristotle is actually a very interesting source if you think about rational thought, and we do discuss a little bit of that, of course not today, but again, this is something part of in that course. So we really take this is just to show you that the deeper perspective is touched. And then acting humanly, that's actually what I want to say a bit more about, using the Turing test. And acting rationally, that's again, so this acting axis is interesting, because what it really means is that it doesn't matter so much what the machinery behind it does. Yeah, so this is not about what the algorithm does. This is about what the outcome is. Yeah, so acting rationally means that whatever it takes behind the scenes to come to a rational decision is fine. Thinking rationally means that we program actually machines in a rational way. Yeah? So this difference in abstract terms is not really easy to grasp, I would think, but it's useful if we now go to some examples that we have made these decisions. So let's think a bit more about acting humanly, and that we discuss using the Turing test, which is actually as far back as we go, apart from one slide on Aristotle. So please to the next slide. Yeah. So the Turing test. And the question asked by Alan Turing in very early, 1940s, 1950s, is, can machines behave intelligently? Yeah. So here you see acting humanly. Behave is a different word from think. Yeah. So the question is not necessarily can they think like humans, because Turing was pretty well aware that the kind of machinery he used to build an artificial intelligent machine was pretty different from the kind of machinery in heads of people or animals. Yeah, so he was interested in whether the outcome of whatever that machine was doing could be called intelligent. So what he devised is known as the Turing test. And who of you knows the Turing test? Just knows what it means. You can there's a share, there's this sort of this raise your hand button that you can use. So I'm doing it right now. Yeah, so I'd just be interested. Again, in Zoom, we have this very neat quick poll function, which is a lot easier because I see numbers, but I can see some show of hands. That's nice. So, would anybody be comfortable speaking up and saying, well, in your understanding, the Turing test is? Still a hand raised. So does that mean that we actually have a candidate to do this? Okay, hands going down quickly, which is totally fine. Yeah. So actually, my reason for doing this is giving you the space maybe to speak up, and I totally understand that you don't necessarily do it in this context. In class, yeah. So especially now in the hybrid and online world, it's somewhat harder. But as said, we have this webcam protocol, and we have rooms where actually people are pretty present in a hybrid sense. Now we, in class, do a lot of things discussion based. Yeah. So when we teach this course, there's a constant going back and forth. This is something I wanted to say, and we don't need to discuss much now. Yeah. So the Turing test is an operational test. So can we go to the next slide, please? I don't see the next slide. Yes. And what the Turing test does is very simple in design. It places a human interrogator behind some chat connection with an unknown other. And that unknown other can either be a human or it can be an AI system. Yeah, and there are different versions of the Turing test. Yeah, but the Turing test, in the sense that I think is interesting for thinking a bit more about this original question that Turing asked, what it is, so whether machines can behave intelligently, is like this. Yeah, so and the question asked to that human is, are you currently speaking to a human or a machine? And if the interrogator can't tell the difference, then Turing says, well, then we can safely say that this machine is intelligent beyond reasonable doubt. Yeah. So the point being made is that whatever this system does, it has to be intelligent, because this human interrogator could not even distinguish between this being a real human or an AI system. So, and on the next slide, slide 13, we meet Daniel Bennett, who is a philosopher, American philosopher, who wrote about many fields, but also in a very interesting way about artificial intelligence. Also pretty early. Yeah? So the things we read by him about artificial intelligence in the context of this course is actually from the 1970s, 80s, and 90s. Yeah, and he thinks very highly, Daniel Bennett thinks very highly of the Turing test, and says, even so, in his case, 30, 40 years later, he was claiming that it hadn't been solved in a convincing way. So that there was still a real challenge for AI to build a machine that could pass the Turing test. But he was saying, he was adding some important things. Of course, an important addition is that the human interrogator has to be allowed to ask any question. Because for domain-specific chats, so to say, it's a lot easier to build a machine that can act like a human. Yeah, and there are multiple demonstrations, again, that we won't go into now, but there are real experiments with domain-specific Turing machines where it's very hard to tell the difference between the machine and the real person. But Daniel Bennett says, if the interrogator can, however, ask any question about any subject, then it must be really easy to tell apart machines from people. Yeah. So, in a nice example that Bennett gives is so what the interrogator could ask is take the letter D and take the letter J. Now, rotate the letter D 90 degrees clockwise and join the G under it. Which weather condition does the result remind you of? So what's the answer? Are you machines or are you humans? You can type in the chat, you know, rainy, excellent. Yeah, very, very nice that you solved this so quickly, of course. Yeah, so we're humans, you're humans. I'm convinced. Because this is one of those nice tests. It's very, very easy, then it says, to program a machine such that it can solve this. Yeah, very easy. Probably even without, so before you are now taking this program, some of you can definitely do it. Yeah, and if you're first years in the data science and AI program, you can program in a few lines of code something that can solve this puzzle. The thing is, then it says, if you need to program a machine that didn't see this specific puzzle coming, so that was prepared for this puzzle and any other puzzle that you could come up with, then you're lost. And then still any AI system is lost. This is actually where I want to round off. So can we go to the next slide, please? Yeah, so this is a bit of a busy slide. I should have put it in there. We set up some of these things already. Yeah, so this is, maybe skip this slide and go to the next one. Because my final thing is a little test for you. If a machine fails the Turing test, what does this imply? Yeah. So let's say open the chat, then I will count. Okay, there the answers are coming. I was going to say then all of you together in 5. Yeah, so 1, 2, 3, 4, 5. Yeah, this is great. So as I expected, the question produces variation, which is good. Yeah, so because there's discussion possible about this question. My own answer would be it implies nothing. And let me end by answering or by explaining a little bit why I say that. Yeah, so if a machine fails the Turing test, all this means is that this user was not convinced that this machine is not a machine, is not a human. Yeah, so the interrogator managed to find out by asking clever questions that this machine could not deal with, but any human could. Yeah, so maybe rotating the D and putting the J under it is one of those things. Any human can do it. Ask a 5-year-old or maybe a 7-year-old, and they'll probably be able to tell you the answer if given some time. Yeah, but in principle, a machine not programmed to do it specifically can't. Yeah. But it's still possible that you're dealing with a machine that is intelligent in a very different way. Yeah, so intelligence in machines must not necessarily be defined in terms of being able to do stuff that humans can do. Yeah. So the point, and this is a point that Turing himself is already making. So machines who fail the Turing test can be intelligent, can show intelligent behavior in certain ways, yeah, in certain domains maybe. But this is still different from this sort of general intelligence that we would expect from another human. Domain general, and if the point of the Turing test is that it's a one-way test. So if the machine passes the Turing test, if you really trick the interrogator into thinking that it was a human, then it means something very important. Yeah. So if it fails, it means nothing. It can still be intelligent in a different way that doesn't look like human intelligence. If it passes the Turing test, then Turing was saying this is intelligence beyond reasonable doubt. Yeah, because whatever that machine can do, if it can fool someone into thinking that it's a human, that is definitely intelligence. And this is what we can say is a quick probe test. Yeah, so in Turing and Bennett's sense. And it sheds some light on what artificial intelligence is or what it can be, but it also leaves a lot of space for discussion. And one discussion point we have now treated a little bit, which is this discussion point between domain specific and domain general knowledge. Yeah, you can program a machine to do something specific. This can still be something specific and intelligent, but it's not this domain general thing where you can basically, without knowing what's coming, solve just about anything. And that's where I will leave it now. Maybe for some of you next year, the part 2, 3, 4, 5, and 7, etc. Of this discussion, because every week is a perspective on artificial intelligence in this course. Final word is this is not a very typical course. Yeah, so every course is a course in and of itself. And clearly, if you now do proefstuderen, you might base your whole impression on what you've seen today on, oh, this is what the program is like. No, I think 70% of the courses is pretty different from what we've done now. So this today shows you a little bit of a course that is special in the sense that it's a discussion-based course. It's aimed at giving you perspective, giving you a bit of background and history, and it's a lot based on trying to make you critical thinkers as AI developers and researchers. Thank you, and over to you, Roy.
Thanks, Max. Let me just share my screen, hopefully.
Yeah, hope it works for you.
Does this work? Can everybody see my screen? Ah, great. Okay, hi everyone. Let me introduce myself. My name is Roy de Klein. I have a background in computer science and in cognitive psychology. And in the Bachelors of Bachelors of Data Science and AI, I will be teaching the Introduction to Cognitive Science course, as well as the Cognitive Robotics course. I'm an assistant professor working at the Cognitive Psychology unit. And I brought some slides from a course that I teach, not in the Bachelors of AI, because the Cognitive Robotics course is a second-year course, and this is more like an introductory course that I'm teaching somewhere else. But it does cover some of the material that we'll be touching on in the Cognitive Robotics course, namely cognitive and evolutionary robotics. So if you have any questions at any moment, feel free to just unmute yourself or raise your hand or do something to catch my attention, and I'll be happy to answer any of your questions. Until what time do I have, Max?
Until 11.
Oh, nice. All right. Well, then let's dive in. Let's get started with cognitive and evolutionary robotics. So of course, let's start with what are robots? And we all have this idea of robots from science fiction, of course, but there should be a formal definition of robots that we can use. And most people would argue, well, robots are different from regular computers in the sense that they can interact physically with the environment. And then there are different categories. Of course, we have the robots that we know from factories, right? That help in manufacturing cars, etc. The so-called manipulators. Then there are mobile robots that can move around, so they have some mechanisms for propulsion. And humanoid robots, basically mobile robots that look like humans. So here on the right, you see kind of like a humanoid robot in the sense that it has 2 arms and 2 legs by which it can move around. It also looks to have 2 eyes, right, for as sensors to perceive the external world. So the legs and arms here we would call effectors in the sense that they affect the position or the state of the robot itself, and sensors in the sense that they can sense the external world. So here's a very simple research robot that has different types of sensors. So on the top left here, you see ultrasound sensors, for example. You see wheels that often include shaft decoders, basically keeping track of how much the wheel has turned in which direction. That can be used for navigation, for example. Here on the bottom left, we see infrared floor sensors, also often included in mobile or in robot vacuum cleaners that prevent them from rolling downstairs and breaking themselves. And here on the bottom right, you see kind of like an RGBD camera that it's kind of like a webcam, but also includes depth information. So humanoids also tend to have force and torque sensors. So, for example, if you shake a robot's hand, the robot needs to have some idea of how much pressure it's exerting on the hand, because, of course, robots can be far stronger than you. It can break your hand if you try to shake a robot's hand. So the effectors of a robot here, basically here on the bottom right, you see a PR2 research robot that has, what did this have? Well, this is an arm with 7 degrees of freedom. And with degrees of freedom, what we mean is the independent parameters that you can use to describe the state of a system. So using only a 1 degree of freedom effector, you only get this pinching movement, right? So 1 parameter is enough to completely describe the state of the system. But when you compare that to the human hand, which has 27 degrees of freedom, you can ask yourself, well, do we really need that many degrees of freedom in a hand? So if you look at a PR2 hand with 7 degrees of freedom, can a human hand really do so much more? And how does the human brain actually control these 27 degrees of freedom? It basically seems that the human body is heavily over-parameterized. And the human brain needs some pretty smart wiring, so to say, to actually perform actions. And this is also something that we will touch upon in the cognitive robotics course. Basically, nature over-engineered our hands, I think, is the conclusion that we can read. So here we see the first robots, basically. So first commercial robots, Unimate, the first robot used in a production line. Here you see it on the top right. So let's take a look at these very simple robots and what we can do to control them. How do we control such a production line robot? Here of course we have the advantage that the number of degrees of freedom are pretty limited. So an early industrial robot like Unimate would have a control program that looks something like this. So we have a couple of effectors. We move effector 1 to angle 19. Let's assume that this robot is working on a production line. And then we move effector 6 to angle 32. And then we performed an action. And then we move effector 1 back to angle 0 and move effector 6 to angle 0. So we return to the initial position. So assuming this this robot works on a production line and these commands basically cause the robot to pick up some stuff from the production line, what could be a problem with a control program like this? So this is a robot working in a physical world, not a perfect simulation. It's an actual physical world. Why would this program... Okay, Milo says it can't detect problems, and that is exactly what I'm alluding to. So this assumes that if you move effector 1 to angle 19, apparently there is some kind of object there. Of course, in the real world, even in the production line, there is some slight variation as to where objects are. Probably they are around the same location, but there's no guarantee that every object is in the exact same location. And then we move effector 6 to angle 32. Well, of course, you get the same problem here. So it's not very robust to disturbances. How can we tackle that problem? Well, one way is, of course, to design a different type of controller. So this is known as a feed-forward controller. It doesn't take in any input from the external world, basically, right? It just performs pre-programmed actions infinitely, basically, and then hopefully everything goes right. But of course, if something goes wrong, the arm will still keep moving, and that's not what it's supposed to do. Of course, there are advantages. If you know exactly where objects in the real world are going to be, then this is a very fast control program. It doesn't have to sense the external world, which is often very slow. But yeah, it's very much non-adaptive. So what you could also do is reprogram this into a so-called feedback control system. And for example, this is what it looks like. Repeat until distance equals 0, or some kind of, error surrounding 0. Move effector 1 left by 1 degree and move effector 6 right by 1 degree. And we keep doing this until this distance has decreased to around 0. And here it's very clear to see the feedback element in this loop, right? So what makes this slow is this first line. Apparently we have to decide if distance equals 0, which includes, of course, doing some kind of sensor measurement from the environment, like I said, which is often slow. So this is slower, but it is far more robust against disturbances, because if now we have to move 2 or 3 more degrees to the left or to the right, this control program is actually able to do that. So it's adaptive, robust, slower, and of course it depends highly on the quality of sensors. So here we need a sensor to actually sense the actual location of the object we are trying to manipulate. All right, so much for very, very simple control systems. Some humanoid robots here. The first humanoid robot, the Wabot 1 from '73, here you see on the left. But you can clearly see the humanoid nature of these robots, right? So there are 2 arms, 2 legs. It doesn't say much about sensors, but I believe at least Asimo had some kind of RGB, I don't think RGBD, but some RGB sensors, just webcams basically to move around and to do basic navigation. Semi-autonomous in the sense that they can just move around through the environment on their own. Often processing here in these robots is offloaded to some kind of server, but the robot itself is free to move around. And this is what you see with self-driving cars as well, right? I mean, they're not humanoid or semi-humanoid in this sense, but they use these sensor information to actually solve some kind of problem. So here you see Google self-driving car using a LiDAR on top of the car, as you can see, right? So Google and Tesla, for example, have very different philosophies as to what you need to make successful driving cars. So Google says we need LiDAR information, whereas Tesla's philosophy is, well, human drivers can basically do it with 2 RGB sensors. Why shouldn't cars be able to do it with RGB sensors? So Teslas don't use LiDAR, but they just use RGB cameras. So what can these robots actually tell us about how intelligence works? And this is basically what cognitive robotics is about. So cognitive robotics is not about building robots that work on assembly lines making cars, right? That's not very interesting from an AI perspective. I mean, it's interesting from an engineering perspective, perhaps, but that's not what AI people are concerned with. So basically integrating psychology in the sense that psychology deals with the problem of intelligence, or cognitive psychology deals with the problem of intelligence, right? How can we make robots as smart as humans? So psychologists or cognitive psychologists are interested in this problem because psychology is basically founded on inverse modeling. What you do in psychology, and of course you're not going to study psychology, but you should be aware of the problems that psychology is trying to answer, because for a large extent AI is trying to answer the same problems. Psychology does it the other way around, though. So what psychology does is observe some kind of behavior, smart behavior or interesting behavior, and trying to reason backwards as to the processes causing this behavior, right? So we see a human successfully solving an IQ test, for example, and then the psychologist would ask, well, what causes this human to be able to pass this IQ test? Which is not an unreasonable question. It is a complex question, though. But you can clearly see the direction of reasoning here. We see some kind of behavior, and we try to infer the processes causing this behavior. The problem here, which is actually known as the inverse problem, that there are different mechanisms to produce the same behavior. So how do you know if you get the correct interpretation or the correct analysis? So this is the inverse problem. This is not a good way a computer scientist or an AI researcher would say that you can actually solve these problems. So AI engineers, they take another approach, namely forward modeling. What if we can just build simple systems that do kind of intelligent stuff, and then we know how these systems work because we designed and built them ourselves, right? So there's no question about the processes that cause this behavior. And this is what Max was alluding to earlier in his talk. Simple systems that give the illusion of intelligence. But of course, the question is this really the illusion of intelligence, or is this basically what intelligence is? Let's take a short look. Valentino Breitenberg was a, well, cybernetician, I guess you could say. He was a neurologist by training, but he was very interested in cybernetic systems. So how can we build systems that perform intelligent action using very, very simple elements? He called this synthetic psychology. Basically, we are building stuff that is intelligent. And he shows that we can create complex behavior through very simple designs. Let's take a look at the most elementary design that Breitenberg came up with, which is this. Basically, this is a Breitenberg vehicle. So here we have a sensor, and this sensor is, well, sensitive to whatever, temperature, light, let's say temperature. And we see that this sensor is connected to a motor, which is right there. It's a wheel, basically, for the robot to move around. So if we say that this sensor is sensitive to temperature, what will the behavior be of this robot as a function of temperature? And if we assume that this connection is a linear connection and it's a positively linear connection. Feel free to unmute yourself. All right, tough crowd. Well, let me say something about. Oh, we got a message. Yeah, exactly. Roman says the higher the temperature, the higher the speed, which is, of course, very simple behavior, right? But Breitenberg says, well, if we would observe this behavior not in a robot, but in an organism, we would say it a bit differently. What we would say, if we would see this in an organism, we would say, well, this organism doesn't seem to like high temperatures, because whenever the temperature is high, it moves away from the high temperature, right? The motor speed is increasing until the temperature gets lower, and then the robot will come, then the organism will come to a rest at a place where apparently the temperature is lower. So we built this thing, this vehicle ourselves, right? We just know that there's this linear relationship between temperature and motor speed. But if we would observe the same thing in an organism, we would have some kind of value judgment towards it. We would say, well, this organism doesn't like high temperatures. Would we say that this robot doesn't like high temperatures? Not normally. So maybe there's some kind of semantic problem here. Maybe we just have problems assigning these values to synthetic systems. So is this intelligent behavior? I think most people would argue that this is not intelligent behavior, but if we try to reason through why we wouldn't call this intelligent behavior, then we run into some problems. Let's take a further look. And move towards some more complicated vehicles. So now Breitenberg says, well, we can extend our vehicle, of course, with another sensor. So let's now assume that these sensors are sensitive to light. And we have now vehicle A and vehicle B. And note that these vehicles only differ by the wiring of their sensors and motors, right? Vehicle A has basically the left sensor connected to the left motor and the right sensor to the right motor. And vehicle B has it crossed, basically. So the left sensor activates the right motor. So if we assume that somewhere there will be a light source, let's assume on the top left there will be a light source, what would the behavior of these robots be? Think about this for a second. If there would be a light source on the top left, what would robot A do and what would robot B do? Miel says A would move away from the light source and B would move towards it. Exactly. That is exactly what they would do. Let's take a look. This is the behavior of these robots. So both of these vehicles will spend more time in places where there is less light, right? That makes sense. They will move faster and faster as they come closer. What you then see is that A will become restless and avoids the source and then calms down as it gets farther away. And vehicle B will move towards the target, hitting it, and almost showing some kind of aggression, right? So it's very clear that B would speed up as it gets close to the light source, orient itself towards the light source, and with high speed run into the light source. And again, what Breitenberg would argue, if we would observe the exact same behavior in an organism, we would call it aggression. And perhaps the behavior of vehicle A we would call cowardice. It avoids the source and calms down as it gets farther away. So, of course, what Breitenberg is alluding to is same behavior, robots versus organisms. Why do we assume that these organisms have values and intelligence, whereas if these synthetic vehicles show the same behavior, they do not? And then, of course, some of the critiques at first were, well, these are all, of course, thought experiments, but you can very, very easily program, for example, a Mindstorms robot to show the same behavior. This is basically what you would do in a Robotics 101 course, just programming simple Breitenberg vehicles. And then, of course, you can extend these vehicles with multiple sensors sensitive to temperature, light, oxygen, right? So you would have robots that dislike high temperatures, dislike light bulbs, prefer oxygenated environments, etc., etc. And then, of course, is this cognition? Is this thinking? Are these values? Is this knowledge? It raises all kinds of questions to see that you can have very complex behavior through very, very simple designs. And Breitenberg would say, well, are humans any different? I mean, we have brains, we have wires between basically our sensory organs and our hands and our feet that cause us to move around. How are humans any different? Are humans maybe just over-engineered Breitenberg vehicles? It gets more interesting if you say, well, let's not talk about a linear relationship between sensor input and motor output, but you can even make it nonlinear, right? Where you have vehicles that wait until the activation of the sensor rises above a certain threshold, and then you can actually simulate decision making by that. So these very, very simple designs can produce very, very complex behavior. A step further would be to get rid of the direct connections between sensors and motors, but instead put an artificial neural network between the sensors and the motors, basically increasing the computational capabilities of these robots. There is not enough time to dive into basically how these neural networks can perform computation, but artificial neural networks multi-layer are actually Turing complete in the sense that they can compute any computable function. So you can actually build some pretty smart robots. If you're interested, join the bachelors in artificial intelligence, and I'll tell you all about it in the second year. And I'll give the floor back to whoever owns it. Thank you.
So hello guys. Yeah, for now we will have a small Q&A, or actually small. We have an hour long. Feel free to send any questions in the chat, and we will get to them. I have two other students with me. Maybe they can introduce themselves.
Hi everyone, my name is Shaif. I'm a third year a student doing the Artificial Intelligence Bachelor, and I'll be answering your questions today.
Hi, I'm Sanne. I'm also a third year Artificial Intelligence Bachelor student. So if you have any questions, let us know.
There was already one question, which was at the end of the first presentation, so we can answer that. The question was by Ragat. Do we need a master's degree for a job? Roy, could you mute yourself?
Oh, sorry.
Yes, thank you. Well, you don't actually need a master's degree. It's not an official requirement or anything, but you do often see that jobs do like a master's degree. So it's not a bad idea to get one, but it's not necessary, especially if you want to become a software engineer. There are loads of bachelor jobs for it as well. Then
Can I
Maurits
very
sent
briefly break in?
yeah, of course.
I need to teach in the offline world very soon. That's why I brought my teaching jacket, because I'm on my way on probably what's going to be the last on-campus course of the year, and maybe for a long while. I'm a bit worried. Thank you all very much for being here, for your attention. Very good to see you in this large number. All the best in decision making over the coming weeks and months, and who knows, maybe see you next year. Bye bye.
Bye bye.
Okay, so in the meanwhile, a few extra questions came up in the chat. Saif, maybe you want to take one?
All right. So, Maurits de Haan had a question. How many papers / essays do you have to write? Well, this is of course a technical bachelor you're doing, so there's a lot of programming involved. But even though it's quite technical, you still have to do a lot of writing. You need to learn how to do research, which is necessary to finish your bachelor doing your thesis. So I would say it's quite. You have to write quite a few papers, definitely. And it depends on the courses, of course, but yeah, you can expect to write at least one paper every semester. So I hope that answers your question.
Let's see. Will the colleges be given in multiple buildings or just one, and which? Most of the time it is in multiple buildings, but we do have one campus. So the campus is just outside of Central Station by 5 minutes or 10 minutes by bike. And you do need to walk between the buildings, but it's not that much, and you do have some time. But it is in multiple buildings. Do you also have to study in The Hague? No, we don't, right?
No, we don't.
No,
Only the
no, we don't.
economics.
Yeah.
I see multiple questions about the mathematics test, and if Dutch students can also join with the mathematics test. Yes, you can. And I will just send the website at which you can do that. It's called the Boswell Beta Institute. They have the Boswell Beta test. It's the only mathematics test we accept. It is really comparable to the mathematics B test in high school. So yeah, you should be able to do it if you want to join, and it is necessary. Also, the lectures are recorded and will be put up online in about a week.
All right. There's a question about the admission requirements. I think this is similar to the previous one, but yeah, you need proper math. So the test Job just talked about, that would be necessary, or wiskunde B examen would also be necessary. And yeah, that's actually the only thing you need to join the bachelor.
How big is the component robotics? Well, we do have some robotics courses, but the first year is mainly some basics in mathematics and programming, because you need all of that to be able to build robots. but we don't really build the robots themselves, but we do program them to do things or to solve certain problems. And how big? Well, we do have some courses in each year with robotics.
At the top of my head, there are about 4 courses, I think. 4 or 5 courses.
Yeah.
Raghat asked the question, is data science and artificial intelligence a tough course? Well, kind of. I already told you about BSA, the Binding Study Advice, which is basically whether you can continue your program or not. If you don't get the 45 EC in the first year, you can't continue. And you see about about 40 to 35% doesn't get their BSA. So only about 60 to 65 does, which means that there is a 35 to 40% dropout rate. So you can, I think, conclude that it isn't that much of an easy study, but it's also not impossible. And there are even people who will do a double bachelor with psychology, which is insanely difficult. But it is tough, not that tough.
Yeah, so if you do proper planning, if you do all your homework, you will get your BSA, of course.
Also one about what was your experience with the online teaching last year? Well, all of the professors did their best, but well, I don't know about any of you, but sitting behind your laptop all day in your room is not really fun. So I do like it that we can go to the campus again and just interact with everyone and talk about certain topics. Let's see. There's also question about inverse wiring.
There's the question from Travis. In what way is the inverse wiring of our brains in relation to our anatomical functions related to positive output given stimuli? If instead a negative output could instead be produced to begin with, or is this physical? And that this inverse wiring is the only or at least most evolutionary desirable to produce the inverse relationship? Good question, Travis. I don't know. I don't think any of us do know that at the current state, so I think we will skip on it. Then the question from Merel. Can you also do a master's in software engineering after this bachelor, for example, the master's at UvA? Yes, you can. And you can even go to Delft, to TU Delft. But for that, you do need a in-between year. The previous students could immediately go to Delft. It's a technical software engineering or technical computer science, excuse me. But you can also do the software engineering masters or bachelors at UvA or any university.
I want to add one thing to it. So you can you can do more things than software engineering. You can also do, of course, artificial intelligence at another university, but also psychology and also cognitive neuroscience on Leiden. So you have plenty of options for the master's degree. And Travis, it might be if you want your question answered, you can maybe mail Roy de Klein, the previous speaker. And you can look him up in the website, and maybe he can answer your question. All right.
Do you have to have any computer science background? No, you don't at all. Just the mathematics is a requirement, but you learn every programming in the first year, so you don't need to have any background. If you do have any computer science background, fun, but it's not necessary. What is the approximate man-woman ratio? Not that much. I don't know the exact numbers. Joep, weet jij die?
Yes, I do know them. It's about 85% male. So, and at regular
go
computer science, it's
Tell me.
about 90%. So there's an extra 5% of female participation. Can you actually work a part-time job with no Dutch language knowledge? Yeah, there are some jobs, of course. And also, I think in the recent years, you also see more and more international students in the restaurants or cafes. So it's definitely possible. There's also remote jobs, or you can be a teaching assistant, or you can do what I do and talk here. There are definitely some part-time jobs that you can do alongside your study without any Dutch language. But I feel like if you come to the Netherlands, you will probably pick up Dutch in a few months. So yeah, it will sort itself.
What masters can you do with this bachelor in Leiden? A lot. So what we just mentioned, I'm not sure what all of the masters are, but you can of course do the computer science master. You can do, I think we also have a cognitive neuroscience, artificial intelligence master. Basically anything related to computer science or artificial intelligence. Yeah.
There, on the introduction I gave, there's a slide with a lot of options. If you go watch this back in a week or something, you can look at the slide, and there are plenty of options if you want to see them all. Will there also be making an own software related to AI? Yes, there will be. Of course, a lot of courses teach us about machine learning or some things like that, but it will not always directly include it to making it a real software product. But at the start of the new bachelor, there will be courses that actually do include some real AI in your own software and even some data science. So that's cool, I think.
And I want to add one thing to it. There are also 2 project courses where you have to do a big project with a group, and you can involve AI into it, of course. So you will definitely get a chance to implement your own AI.
How did you notice the difference between the first year and high school? Well, I think this goes for all university courses. In high school, a lot of stuff is done for you, but at university, you really do have to do it yourself. But yeah, I don't know if any of you have to. But I mean, it is more work, but it is something that you like doing. So in that case, it's not really. I think my internet's not that good.
Yeah, we can hear you. It sometimes
Oh, okay.
stutters, but it's all rightish.
Okay.
But yeah, the first year, it is more difficult, of course, than your high school, but it is manageable as long as you keep some planning. Did you have data science in your program, or is this something new in 2022? How will the program change with respect to what you have now? I think the biggest difference is that it will all be in English. We had some Dutch courses, but that will be gone. But the content is almost not changed. I just heard Saif talk about 2 software group projects that changed to 1. So there's one gone. There's an extra data science course, which we didn't get, but it's mostly the same. And we still did have some data science. It's just not as much as you will have.
All right, Merel, what programming languages do you learn during the bachelor, and do you need to have any prior knowledge about those before starting. So during your first year, you will definitely get a proper background into programming, good fundamentals, the things you really need to know how to program. So you don't need any knowledge of programming before you start. You can go in completely blindly, and still get your bachelor's. And what programming language do we get? So in our year, I'm not sure how it will change in your year, but we got C++. It's like a low-level language that runs really fast, and it's a bit more difficult to write than other languages, but it's a nice basis to have. And you will get Python, of course, which is like the bread and butter of data science and AI. So that is what you will be getting. But I'm not sure about C++. Maybe Job knows.
There will still be C++. So you will still have that through computer science basics. It might also be good to mention that there will also be other languages involved. For example, for your group software project, I'm working with TypeScript now because it's what we decided on as a group was the best fitting language. And there's also a course that uses Java. But that doesn't all matter too much, as you, if you can type in one language, you can almost switch to any language pretty easily because the logic stays the same. Of course, syntax changes, but most of the logic stays the same. So if you can do one language, you can really fast adopt to any other language.
Yeah, exactly.
I see the question of Tarek. Is it possible to get a copy of the slides? I'm not quite sure, but at least this is being recorded, so you can watch back the recording. By the way, the recording will be made available on the site. You will not get an email.
Okay, if you study data science and AI and you want to do a minor, does this minor have to be related to AI? I believe this is completely free. Is it correct, Job?
There are a few you can choose from. So there are just computer science minors, and as an AI student, you can pick one of these. So
Okay.
it's not that you can do a minor of the law school, but you can do a minor that's more focused on bio computer science, for example.
Yeah, and you can also do psychology minor, for instance.
Yeah, definitely.
Yeah. Okay. Yeah. Okay. Which aspect intrigues you guys the most about this course of study? I think this is fun if we all answer it, because I think we all have different opinions about it. So I'm personally really interested in like neuroscience and how human decision making works, and that's something this program really puts emphasis on. There are a lot of alpha and psychology courses, but those are really necessary to understand how decision making works, and that's for me personally a really fun thing to learn. Yeah, Sanne?
Yeah, for me, I when I first started, I started the computer science course, and about half a year later, I switched to artificial intelligence. But what I really like is I'm still very interested in computer science and just hardcore programming. So I do like it that artificial intelligence has both hardcore programming and also a lot of stuff about the brain and neuroscience and how that works. And I also like it that almost everyone in our course is very how do you call that, motivated. So when we have a lecture, we can just all talk about how it could be, and just also a bit of I don't know, philosophical parts. I like that as well. I think mostly those two.
My main interests lie in the mathematics we get and machine learning. I really enjoy that. We have an entire course on machine learning. You learn all the different models. You learn exactly how they work, not only how to use them. So that's my favorite part. And with that, of course, comes also deep learning, but we don't use that too much. But you will probably do that more because you have more data science. Is this course focused more on programming or understanding the system? I think, if I get your question correctly, it is more focused on understanding the system. Yeah, we do use programming, but just as I mentioned, for example, with machine learning, it's not that you are just going to apply machine learning to some data, just use a library and then, it works, all right, we can do this. Now you're actually going to learn about the system, why this was made in such a way, how we could recreate it or how you could even improve it. That's more of the focus. If you want more programming, that's usually in what we call HBO in the Netherlands. That is usually more applied, and this is quite a bit more theoretical.
We also missed one question about ratio international and Dutch students.
Sorry.
I think you know the numbers.
Well, we actually don't know the numbers yet because next year will be the first year that we actually do have this bachelor. So for what we are doing, we are still actually a computer science student with a very, very large AI minor. That's how at least we are in the system. You will be the first true data science and AI student, which and that will also be the start of the international program. So that also means that for the first time there will be international students. So I don't know, but I guess about 30% will be international. But I'm not. Yeah, we just don't know yet. But this is about what I see at open days and meetings such as this one. It's usually about 30% international.
Okay. Thijs had a question about how theoretical this study is. Like Job said, so we don't really learn how to apply stuff. Well, we do, but the main focus is, of course, on how it works and what the math, what the background is of how of certain algorithms. So it's quite theoretical. You will learn things about complexity. So how fast does a program run? You will learn a lot of math, of course. Well, fundamental informatics like set theory and logic. Those are also really important things you will learn. So compared to a more practical study, this one is really theoretical, but it gives the advantage that you will learn things more quickly because you have such a strong theoretical background. So I see it as an advantage.
We do have in each course we do have about 2 to 3, maybe sometimes 4 practical assignments where you need to work with the stuff you've learned and for example, machine learning. So we had some assignments about classification and how that works. And you just need to try to figure it out for yourself. So it is theoretical, but we do work with the things we learn. What laptop do you recommend for the study? I think that's a question that's answered a lot, but I think it's also kind of what you want for yourself. For example, some people want a laptop that's, for example, lightweight and or a large battery or something. But I do recommend a laptop with 8 gigabytes of RAM, 16 also all right.
Yeah, and maybe
truth
something.
is, it doesn't matter that much what kind of laptop you have. You can even do it without a laptop because there are computers available for you at all times if you want to. They are just desktop computers. But I do recommend just it doesn't have to be a new laptop or one of the fastest MacBooks, but it is just nice if it is at least a bit fast, that not only booting up already takes 10 minutes. Just be able to work with it and it's all fine.
Yeah, and maybe something lightweight is always nice to have, because that's much nicer to carry. I mean, if you will be bringing your laptop every day, then it's more useful to not have a heavy bag. So maybe that's a good advice.
I would recommend a laptop that either runs on Linux or maybe Mac OS as well. Windows is not that like the terminal of Windows is written in different language. So if you want to program with your own laptop and you have a Windows laptop, might not be the easiest transition from what you learn.
Yeah,
You
it
can
can work.
You can of course always use a virtual machine,
Yeah, of course, yeah.
or also install Linux side by side. And there's even a lecture about how to do that. That's optional if you want to learn about it. I see the question from Tarek. Do you still need to do BOSWAP beta certificate if you have an European certificate? That really depends. It depends on where you even live or what level of mathematics you got. What I would do is send an email to the admissions office. They know the exact things, and they also handle the requests. So I think you should send them an email.
All right. What are your favorite places to go in Leiden, especially focused on nightlife? So I don't know anything about Leiden actually, because I live in The Hague, and well, all my social life is in The Hague. So maybe Sanne or Job knows it better.
Yeah, I myself, how do you say that in English? Sorry, I have a bit of an error. I do, live in Leiden, and I'm with a student association here, so I mostly go there if you want to focus on nightlife. Well, now with Corona, there isn't much nightlife, but normally there is. But you do have a lot of cafes and a lot of bars that a lot of students go to, where you can meet other people, or where you can go with your friends. There are a lot of bars and cafes, so if maybe you can look them up. There are a lot of nice. I think that especially in the center, probably around every corner there is a bar where students go. So it's there is not a lot of nightlife if you're interested, and you can also join a student association if you want to really dive into the student life.
Yeah, so it's lots of fun. And the nice thing about Leiden is also it's quite close to Amsterdam, like half an hour, I believe. And it's really close to The Hague and Delft, and those are really crowded with students. And if you ever get tired of Leiden, you can always go there. And if you go to The Hague, I would suggest Grotemarkt or Het Plein. It's like near the center. Those are fun places to go to. All right. Next question
is useful in continuing into software development later. Yeah, I think so. It might depend on what kind of software you're interested in. But I think either this course or the computer science course is a useful start for software development. We do have in AI, we do have 1 or 2 courses about software development.
Mm-hmm.
So yeah.
Also, of course, as part of an AI, you will come across loads of algorithms. So yeah, and algorithms are mostly what software development is often focused on, apart from the user interface stuff. So that does mean that even with AI, well, it not being truly focused on software engineering, you can definitely become a software developer if that's your goal.
Yeah, You can maybe even do a minor into in software development.
Yep.
So you can get courses in testing or how to build a nice architecture. So I would recommend that.
Yes. How do you complete a subject? Asks Robin. Well, there are multiple ways you can complete a subject. Each course, decides on their own what their best method of testing you is. Some courses have a presentation, but most of them do just have a regular exam. Some also, or most of them actually, also have some practicals included that are graded. So most of the time, it's just a combination of some things you did, and they each have their own contribution to your grade.
And you can also look into the studiegrids or the study guide. You can Google it. So if you look up a course, it will also tell you how it's examined, whether you have to give a presentation or do something else. So you can look it up in the study guide. I mean, sorry.
And most of the courses do have an exam, a final exam, in combination with a few practicals. But there are also some courses where it's just a practical, like one end project, one final project where you are graded on, so there isn't an exam. So it kind of depends on the course. How does your schedule look like during a week? Well, I don't know if you mean just artificial intelligence wise, or also like including social life.
I think at least for the study part, you usually start the day around 10, sometimes a bit earlier, depends on at what time your course you start for the day. Then there are some work groups you go to. Most of the time there are some assignments you have to complete for some deadlines, so you can work on that. And overall, of course, it depends from student to student. But after you get used to it, it doesn't feel that busy. I think I speak for most of us. It's just it's not 9 to 5 every day or something. It's how you want to how you want to do it. There's only some things you have to attend, but most of the things are not obligatory.
Yeah, what I also like, what is different with university versus high school is that you can kind of plan your own day. So you do have some lectures or practicals that you do need to attend, but most of the time it's just you working on it yourself, either on campus or at home or with other students, wherever. So it's not that you need to be at campus 9 to 5. You can also just go for one lecture and then and then work at home, or there is a lot of assignments and self-study, if I can say it like that. You can also do some work in the weekend if you want to be if you want to spread it out more. It's very flexible, and you do have time for social life next to it.
All right. Question by Travis: Will we be provided with cloud computing resources for training our models? If so, to what extent? For the bachelor, it's not the case, I believe. I believe if you do the master, then you can use the resources of the faculty. But the answer is no. I don't think so. Of course, you can use your own cloud computing resources, like I don't know, launching a notebook into the cloud or something. But the university doesn't provide it for the bachelor. Martin, are there many work opportunities after finishing the program? For example, can you find a good paying job? And if yes, then how long does it take to find one? So even during your bachelor, you can find a software job. It might surprise you, but we're quite privileged as computer science students. We've like a really good position to find a job. And if you find your bachelor, your chances are even higher to get a job. I believe the statistics are like 91% or 95% finds a job within a year. And if you do a master's degree, it's even faster and you have more opportunities. So I wouldn't worry that much about job opportunities. It will be the least of your issues.
How many contact hours are there? From the top of my head, I think that's about 24, 25 in a week.
More about 20. At least 20 is
20.
average.
Yeah. So that means you have to do like,
all right, 20.
yeah. So if you translate that means you have to do like 20 hours of self-study, according to the 40 hours a week workload.
And within the 20 hours of contact hours, there half of that is lectures most of the time, and the other half is work groups or practicals where you can work on assignments together with the students. So it's not that you only have the contact hours and all the assignments are done in your own time. You can work on all of the assignments in the contact hours as well. What is the ratio between working at home and having to go to the university? I think that's what we said about the contact hours. So you have 20 contact hours where you have to go to the university. Not everything is mandatory, but it is recommended to go. And the rest is self-study. So you don't really have to do that at home. It's not like after lecture you need to go home. There's also a lot of places to study at campus or at the university where you can work on assignments. So I think it's 2020. 20
Yeah, about that.
like
Yeah.
And of course, you don't have to go to every lecture if you don't want to. So, and sometimes you can watch them at home. So, if you want to, you can be a lot at home, or if you want to, you can be a lot at the university.
Yeah.
It's basically up to you. Well, I think we have run out of questions. Maybe some people have some last questions.
Is it
possible to attend workshops from home? I think it depends on the course, but most of the time it is possible. However, it is recommended to go to the university for the practicals as well, because that's where you can answer your questions and see if you do understand the subjects of the lecture. But I think it's possible to attend them from home.
Yeah.
I don't know if Job has more.
Yeah, it almost always depends mostly on if you have a work group, like a group of 5 to 6 people that you have to be with, because yeah, they might want to meet physically or they might want to meet online. So that also might change it up. But most of the time, it's also much nicer to be there physically because they can get immediate help from the assistants that are there. But
Yeah.
it's possible to do them at home most of the time. How much free time would you say you have in a week? Yeah, that's also kind of up to you and what kind of grades you want to achieve. But there's still more than enough free time. I mean, a third of the week you're sleeping, and then 40 hours of study. Well, do the math, and there's still a lot of free time.
Yeah, it's not that you the only thing you're doing is studying. There is a lot of time for social life as well, or just free time. It really depends on how you plan your week and what Job said, what kind of grades you want to achieve, and how easy it is for you. Maybe a bit harsh to say, but some people find it easier than other people. And well, if you find it easy, then you have some more free time. Let's see. I've heard that housing is hard to find. So do you have any tips? Yeah, housing is hard to find sometimes. There is a Facebook group which is called. I'm just gonna look it up for you.
Also, I see someone ask for the link to the study kits with all the courses.
I will send it.
Yeah, I just sent it in the chat.
Oh, sorry. Okay.
Oh, now we have the two different ones. Oh, the one you sent is much nicer because you can click on the courses.
Oh, okay. Maybe I will.
Okay.
I'll do it.
I will delete mine.
Okay. About the
there you go.
house, there is a Facebook group called Zoektkamer in Leiden Community. I can send a link in the chat where a lot of houses put up a post if they're looking for a new roommate or roommate housemate. So that's one I would recommend. There's also a lot of other websites. I think there's also a post about this on Leiden University with all different options where you can look. You do need to, I would suggest starting in advance, especially if you live far away. But it's not that it's impossible to find a house. There are also always possibilities. How many students are there in total each year? I am sure.
It's about 80. But that, of course, after the first year, there are some will drop. So it gets to about 50. But it is increasing quite rapidly. And of course, next year there will also be international students. So I guess there will be about 100 in your first year. That's what I guess. But there will be more than enough teaching assistants to still keep it quite personal.
Yeah. Is the study cum laude? I'm not entirely sure what you mean by the question, but yeah, you can get your degree cum laude, which means finishing all your courses with an 8 or higher, on average, of course. And there are certain rules to get a degree cum laude. Like you cannot reset 2 times, I believe. I think you get only 1 chance or 2 maybe. But the exact rules of it are on the website of the faculty. And I can maybe send you a link afterwards.
And the question, how many people get accepted per year in this course? It's not that we have a limit on how many people can get accepted. If you just match the requirements, you get accepted. I do have to mention, there is in the admission process, just when you sign up for the program, there is a very small test that you have to do. It's mandatory. You don't have to study for it. It doesn't take long. But if you do very badly at it, we will just contact you and say, hey, this might not be the study for you. If you just didn't have your day or just didn't want to do it properly, you can just go ahead. Or if you think, I don't care about the feedback, I'm still going to do the program, you can still do that. But you have to do that test. And also make sure that you get a feeling for the program.
Let me see.
We seem to have run out of questions again. Let's wait. Oh, the test will be. Yeah, I don't know when you have to. I think you have to sign up before. I think it's like May or something. The test will be a bit after that. The test is kind of just like a puzzle. It's not hard. You don't have to study for it. It's yeah, somewhat computer science, mathematics related. And if you fail it, it doesn't matter. So just don't worry about it. It's mostly for you to get some feedback on if you will actually like the program. And it will all be explained in detail and you won't miss it.
Any other questions?
I'm not quite sure, Tarek. I think if you mean like for the admission process, your certifications, you need them when you sign up, and I think you have to sign up before May. Yeah, so don't wait too long. If you have like specific date requests for this, you can just email the admissions office. I will put their email in the chat. You don't actually have to give your grades. Sorry, Julia. You can just sign up, and if you have the proper courses in your IB, then it's fine.
Yeah.
And for Maurits, will the studiegid's of this year be comparable with next year's? Yes, they will be comparable. I even believe that it will be exactly the same.
Yeah. The only difference is the third year, right? Because we don't get a we didn't get a minor opportunity, and
Yeah,
they
true.
get. Yeah. What is the? Turka has another question. What is the difference? I mean, the major difference between the first year courses and the second year courses. So the first year is mostly fundamentals, so math, learning how to program, introduction to psychology. What else? Database, of course, logic. So everything you need to know in order to write a program. And the second year is more courses about AI. So yeah, that's the main difference. So first year is more fundamentals, and the second year is more getting deeper into AI.
Yeah, and in the second course, you apply all of the basics that you learned in the first year. For example, machine learning or other AI subjects. Yeah.
Let me see. So for non-EU or EUR students, the deadline is 1st of April. For EU students, 1st May. Oh, sorry, that was another question. All right.
Let's wait
Any
a bit
other
and see
questions?
if something comes up.
Is there such a thing as housing reservation? What do you mean by that? I'm not really sure what you mean by housing reservation.
By the way, there's a lot of housing information on the Leiden website. I'm just going to send a link.
Yeah,
You can
I've
even
already sent the link.
make. Oh, you already did. Yeah, you can make a housing reservation or a housing request via the Leiden University. Yeah. So you can try that.
Yeah, so there is also a housing office which helps international students with finding a place to stay. You can also find that on the University Leiden website. And there is also a thing for Dutch students where certain parts of the year they're how do you say this? If you live far away, then you can only apply to. Oh wait, no. There are certain houses where you can only apply to if you live far away, which is very recommended to look into that, because if you live far away, it might be a bit of a long travel. Might
So
be a
Robin
while
has.
back.
Oh, sorry. Go ahead, Sonny.
Oh, yeah. Might be a while back, but did you have any doubts before choosing this course? How did you decide what to study? Well, for me personally, I started another course initially, astronomy here in Leiden, but I did not like that. So I switched. So I quit that course, and then I started the artificial intelligence course. How did I decide that? I don't know. I just went for what I thought was interesting. What I did was because with astronomy, I didn't really like the physics part, but I did like the programming and the math. And with programming and math, I kind of just came to computer science, and I was already really interested in the brain and how that works. So that just led to artificial intelligence, I think. And how do you decide? I think you just need to go for what your interests are. And yeah,
Yeah.
that's for me.
For me, it's a bit different. So I first started with the computer science course, and then in the first year they told us, "Oh, guys, there's an artificial intelligence specialization. So if you want to follow it, you can do it." So that's when I decided to switch, because I looked into the course program of the normal computer science course, and it seemed like a lot of fun, but it also contained a lot of things I didn't like, such as embedded systems, hardware, compiler constructions, like all the low level stuff. And I don't really like it, so that's why I decided to do artificial intelligence. And when I started, I found out that it's much more fun than normal computer science. So I'm happy with the choice, definitely. And maybe Job, do you?
Yeah, I think I've basically the same view. I signed up for computer science, also transitioned to all that, and then I just decided, hey, I really enjoy algorithms, machine learning, that kind of stuff. It's more in the AI course, so why not switch?
Yeah.
I did not really have any doubts, but I don't think it's weird to have doubts because it's quite a big choice you have to make.
Yeah.
So that's why
And
it's good to be here.
yeah, and let's say even if you find out after finishing your AI course that you don't like AI, you can always do like a normal computer science master's degree. So you can always switch back. That's always an option. All right.
How many research articles do you have to read per course? Do you have an example? I think this differs a lot between which course. So, for example, the programming course in the first year, you don't have to read any articles because it's just hardcore programming, as well as the math courses, you don't need to read any articles. We are in our third year now, and we do have some courses where you need to read a paper, a journal, and then you talk about it with the fellow students, what you thought of the paper. I don't have an example at hand right now.
I do have some. So in the first year, there are a couple of courses where you have to read papers. No, sorry, it's only one. So there's philosophy of AI, and yeah, as the name suggests, it's about philosophy. And during that course, you have to read a lot of papers about philosophy, the theories of Plato and Aristotle. And I believe every week we had to read one or up to 3 papers. So that course was quite intensive with papers. But for all the other courses, like Sonny said, it's not that much. So for like psychology courses, you might have to read once in 3 weeks or once in 2 weeks a paper. So that's quite doable.
What is the difference from Leiden University AI than from Amsterdam AI course? I think the biggest difference is in the amount of computer science we have. We have a lot of it. About 50% of our courses are just true computer science courses. So you will be, at the end of the bachelor, you will be a good computer scientist. That's just what we aim for. It's one of our top focuses. We believe that that is necessary in this field. Amsterdam's approach is a bit more philosophical, a bit more neuroscience, which is a lot of fun. But we think that's more of a nice addition to have than what should be the true core of AI. So I think that's where the biggest difference lie.
So at Leiden, you do get a large computer science background, so you can always go to computer science masters. I think it might be also the case for Amsterdam, but it is more focused on psychology, and here at Leiden it is a little bit more focused on computer science itself. Is it possible to do extra courses of psychology during the first or second year, or is a program too overloaded? Everything is possible, but I would recommend, especially the first year, just getting all of your study points. So just focusing on the bachelor itself. And if
Sanne, you're
I think
inaudible. Yeah,
more
you're back.
courses.
Can you repeat what you said?
Oh, okay. Where was I?
Yeah, that's 5 seconds ago.
Okay. So I would recommend just for the first year just completing your normal course. But if you're studying and you think easy or you have more time, you can always add extra courses. There are a lot of psychology courses, and most of them you can just do next to your normal course. So everything is possible. You can even do philosophy or anything else, any extra courses. But for the first year, I would recommend just firstly focusing on your normal electives. Is quantum computing touched?
Nope.
Yeah,
Nope.
only
I don't think it is.
Yeah, well,
go ahead, Saif.
yeah, sorry. So we had yesterday a lecture about quantum computing. So that's quite fun. But now it's not really necessary for the program, and we don't really touch upon it. They might mention it one time, but quantum computing is still quite in an early stage, and yeah, it's not something the bachelor really handles. But if you do a master's degree, I know there are some courses in quantum computing, quantum information theory that you can follow. So if you're interested in that, you can do the master's here.
Okay. We have less than a minute left, so I'm going to answer your question quickly, Nicolas. Are there any electives that you can choose from? Yes, you can choose your minor. In your third year, there are a few other courses that you can sign up for or choose. So that's it. Thank you guys for being here today. It will be recorded. Or it will be posted online, so you can watch it back. So thank you, and I might see you next year. Bye.
Yeah. Bye. Oh, and if you guys have any questions, just send me a message on LinkedIn or something.
Yeah, you can also email me.
Or email you.
It's on the site. See
Yeah.
ya.
Great. Okay. Bye, guys.
All right. Bye-bye.